Hello students of class 12th. This is your next chapter. Here written it is 3 because I have already prepared it before your reducing syllabus. But actually this time this chapter is 2. Please correct it 2. Chapter 2 Electrochemistry. What is electrochemistry? Electrochemistry is the study of production of electricity from energy released during spontaneous chemical reactions and the use of electrical energy to bring about non-spontaneous chemical transformation. Means the reaction or the process between electrical energy to chemical energy or to chemical energy to electrical energy. Conversion of these two energy each other, that is called electrochemistry. In this, you have already studied this portion. Oxidation and reduction are the two types of chemical reactions which is used to transfer electron or electrolysis. So what is oxidation? Loss of electron is oxidation. And what is reduction? Gain of electron is reduction. So what is oxidizing agent? What is reduced is the oxidizing agent. Reduce itself, oxidize other. So that is called oxidizing agent, and which is oxidize itself, reduce other, that is called reducing agent. In this example of the chemical reaction, zinc in solid state, 2H plus ion in aqueous state converts Zn2 plus ion and H2 molecule is formed in the form gaseous state. So here H plus ion oxidizes zinc by taking electron from it. H plus ion oxidizes zinc. H plus ion reduce itself, and zinc reduces H plus ion by giving it electrons. So zinc oxidizes itself. Now where it is used or how the process completed? It is in the electrochemical cell. The cell that converts chemical energy to electrical energy is called Daniel's cell. Chemical energy to electrical energy. That means you have to take in chemicals and converts into electrical energy. That is called Daniel's cell and has an electrical potential equal to 1.1 volt when concentration of Zn2 plus ion and Cu2 plus ion is unity. That means 1 mole per decimeter cube is taken. Such a device is called galvanic or voltaic cell. If an external opposite potential is applied in the galvanic cell as in the figure given and increased slowly, we find that the reaction continue to take place till the opposing voltage reaches the value 1.1 volt when the reaction stops altogether and no current flows through the cell. Any further increase in the external potential again starts the reaction but in the opposite direction. If now functions as an electrolytic cell, a device for using electrical energy to carry non-spontaneous chemical reaction. For example, in this Daniel cell, zinc solution, that means zinc sulfate is taken and copper sulfate. And electrodes are taken here, zinc and copper electrodes. Zinc and Cu2 plus ion when reacted, zinc 2 plus ion and copper formed here. That means zinc oxidized and copper reduced. And the same reactions, how the work is done here, that is given. Chemical reaction proceed. Electron moves through the inside the cell or the solution, and current flows through the circuit which is connected with the cell. You can see one U-tube, inverted U-tube is there, that is called salt bridge, which connect the two half cells there. This is full diagram or figure of a full setting of a Daniell cell or galvanic cell. So galvanic cells, the device that gives energy of the spontaneous redox reaction is converted into electrical work, which may be used for running a motor or other electrical gadgets like heater, fan, geyser, etc. Daniell cell discussed earlier in one such cell in which the following redox reaction occurs. Zinc converts into Zn2 plus and copper 2 plus ion converts into copper atom. That means what? Zinc oxidizes and copper reduces. This reaction is a combination of two half reactions. Those addition gives the overall reactions. Copper takes 2 electron, reduction half reaction, and zinc gives 2 electrons, oxidation half reaction. These reactions occur in two different portions of the Daniell cell. That means in two different containers, separate container or half cells. The reduction half reaction occurs on the copper electrode, while the oxidation half reaction occurs on the zinc electrode. These two portions of the cell are also called half cell or redox couple. The copper electrode may be called the reduction half cell and the zinc electrode oxidation half cell. Each half cell consists of metallic electrode dipped into an electrolyte. The two half cells are connected by a metallic wire through a voltmeter and a switch externally. The electrolytes of the two half cells are connected internally through a salt bridge. As previous figure you have seen this. Sometimes both the electrodes dip in the same electrolyte solution. In such cases we do not require a salt bridge. But this is rare. At each electrolyte interface, there is a tendency of metal ions from the solution to deposit on the metal electrode, trying to make it positively charged. At the same time, metal atoms of the electrode have a tendency to go into the solution as ions and leave behind electrons at the electrode, trying to make it negatively charged. At equilibrium, there is a separation of charges and depending on the tendency of the two opposing reactions, the electrode may be positively or negatively charged with respect to the solution. A potential difference develops between the electrode and the electrolyte, which is called electrode potential. When the concentrations of all species involved in a half cell is unity, then the electrode potential is known as standard electrode potential. I repeat this. A potential difference develops between the electrode and electrolyte, which is called electrode potential. When the concentrations of all the species involved in a half cell is unity, then the electrode potential is known as standard electrode potential. According to IUPAC convention, standard reduction potential are now called standard electrode potentials. In a galvanic cell, the half cell in which oxidation takes place is called anode, and it was negative potential with respect to the solution. The other half cell in which reduction takes place is called cathode and has a positive potential with respect to the solution. Thus, there exists a potential difference between the two electrodes, and as soon as the switch is in the on position, the electrons flow from negative electrode to positive electrode. The direction of current flows is opposite to that of electron flows. Electron flows from negative electrode to positive electrode through the solution, and current flows with the circuit or wire outside the externally which is connected with the cell from positive to negative electrode. The potential difference between the two electrodes of a galvanic cell is called the cell potential and is measured in volts. The cell potential is the difference between the electrode potentials of the cathode and anode. It is called the cell electromotive force of the cell when no current is drawn through the cell. It is now an accepted convention that we keep the anode on the left and the cathode on the right while representing the galvanic cell. A galvanic cell is generally represented by putting a vertical line between the metal and the electrolyte solution and putting a double vertical line between the two electrolytes connected by a salt bridge. Under this convention, the EMF of the cell is positive and is given by the potential of the half cell on the right hand side minus the potential of the half cell on the left hand side. That is, E cell is equal to E right minus E left. That means E cathode minus E anode. This is illustrated by the following cell reaction example. Copper solid plus 2Ag plus aqueous gives Cu2 plus ion aqueous plus 2Ag. Half cell reaction is cathode reaction. In this, silver ion converts into silver atom. Anode oxidation. In anode, oxidation takes place and there copper solid converts into copper ion and 2 electron is released there. It can be seen that the sum of the above reactions leads to overall reaction in the cell and that silver electrode acts as a cathode and copper electrode act as an anode. The cell can be represented as CuS 1 slash Cu2 plus aqueous 1 slash Ag plus aqueous slash Ags, and we have E cell is equal to E right minus E left, that is Ag plus 2Ag minus E Cu2 plus 2Cu. I think it is enough to understand what is galvanic cell and how it is represent. Now, measurement of electrode potential. The potential of individual half cell cannot be measured because it is comprehensive or competitive word, difference between the two cells. So, we can measure only the difference between the two half cell potential that gives the EMF of the cell, electromotive force of the cell. If we arbitrarily choose the potential of one electrode, then that of the other can be determined with respect to this. According to convention, a half cell called standard hydrogen electrode represented by Pt solid platinum, H2 gas, then H plus ion aqueous is assigned a zero potential at all temperatures corresponding to the reaction. Standard hydrogen cell is there. H plus equation plus electron taking half H2 is formed. The standard hydrogen electrode consists of a platinum electrode coated with platinum black. The electrode is dipped in an acidic solution and poured hydrogen gas is bubbled through it. The concentration of both the reduced and oxidized forms of hydrogen is maintained at unity. This implies that the pressure of hydrogen gas is 1 bar and the concentration of hydrogen ion in the solution is 1 molar. So this is called standard hydrogen cell. And the diagram or figure for SHE, standard hydrogen electrode, is as platinum coated platinum is there, you can see here, and finally divided platinum coated on platinum foil. 1 mole H plus ion is there and H2 gas which is removed. The pressure of this gas is 1 bar. If the concentration of the oxidized and the reduced forms of the species in the right hand half cell are unity, that means one cell, that is standard hydrogen cell, then the cell potential is equal to the standard electrode potential. Sometimes metals like platinum or gold are used as inert electrodes. They do not participate in the reaction but provide their surface for oxidation or reduction reactions and for the conduction of electrons. For example, platinum is used in the following half cell hydrogen electrode. Platinum coated there, hydrogen gas is used and hydrogen plus ion is in the aqueous form. Acidic solution is present there. With half cell reaction, here platinum is inert. Half cell, only hydrogen aqueous takes electron, hydrogen ion and forms hydrogen atom. That means oxidizing and reducing both takes place in hydrogen. Bromine electrode, platinum, bromine plus or minus, bromine atom or minus. With half cell here, half bromine takes electron and converts into Br minus ion. If the standard electrode potential of an electrode is greater than 0, then its reduced form is more stable compared to hydrogen gas. Note down it, student. If the standard electrode potential of an electrode is greater than 0, that means it is in positive, reduced form is more stable compared to hydrogen gas. Similarly, if the standard electrode potential is negative, that means less than 0, then hydrogen gas is more stable than the reduced form of the species. It can be seen that standard electrode potential for fluorine is the highest in the table, indicating that fluorine gas has the maximum tendency to get reduced to fluoride ions, and therefore fluorine gas is the strongest oxidizing agent and fluoride ion is the weakest reducing agent. Lithium has the lowest electrode potential, indicating that lithium ion is the weakest oxidizing agent, while lithium metal is the most powerful reducing agent in an aqueous solution. It is observed that as we go from top to bottom, the standard electrode potential decreases, and with this decreases the oxidizing power of the species on the left and increases the reducing power of the species on the right hand side of the reaction. Electrochemical cells are extensively used for determining the pH of solutions, solubility product, equilibrium constant and other thermodynamic properties, and for potentiometric titration. And student, this is standard reduction potential of different elements and their ions. You can see here, as already discussed, fluorine F2 gas, fluorine gas, good reducing agent but less oxidizing agent. As we move towards the bottom, size of lithium, oxidizing agent increases, reducing agent decreases. It is tabulated as you can see here. So, which half cell is used as a anode or which is used as a cathode, it is determined through this potential value. I think you have understand what is electrochemical cell, what is galvanic cell or electrode potential through this lesson. Thank you.